This video is to show you how to assemble the conductivity apparatus in order to make a measurement. Conductivity apparatus consists of three parts. The conductivity sensor itself that gets dipped into the solution at this end, a 12-volt LED, which if you examine it closely has one short leg and one slightly longer leg, and a 3-volt power supply. Before you use this, the 3-volt power supply has to have batteries put in it. And when you're using it, there's an on-off button to be careful about. It's not going to work, obviously, if it's off. In order to assemble the conductivity apparatus, lay out the pieces somewhat like I have it here. You have to take note of one important connection. When you examine the LED closely, you will see that one leg of the LED is shorter than the other. That short leg of the LED has to be connected to the negative lead from the power supply. That's the black one. So first I'm going to take those two and connect them, and then I'm going to make a loop. When this device functions, the electricity moves around in a loop from the red through here. It makes a connection through the solution at this end, and then it comes back up through here and goes through the LED. So you just have to connect all the wires in a loop after you've been sure to connect the short leg of the LED to the black lead, the negative lead from the power supply. This video is to demonstrate how to use the conductivity apparatus to evaluate the conductivity of the solutions you prepared in the first part of the characterization of compounds experiment. You evaluate the conductivity of the solutions that you prepared by comparing them to three standards. 1% sodium chloride solution is the standard for strong electrolyte. That means it's a standard for what we will expect to conduct electricity very well. That's a solution that you prepare. 1% acetic acid was mailed to you, and that's the weak electrolyte standard. Weak electrolytes have a moderate ability to conduct electricity. And the non-electrolyte standard is the distilled water that was provided to you in bottles, something like this. It may have been a different brand. I also have here a solution of an unknown compound that we're going to evaluate for demonstration purposes in the same way that you would evaluate the compounds that you're asked to evaluate in the experiment. When you're using the conductivity apparatus, it's important that you wash it off with distilled water between all trials or before you use it in case it was dirty. So this squirt bottle was filled earlier with purified distilled water you were provided with. The first solution I'm going to demonstrate for you is the non-electrolyte standard. That's the same water that I was just washing the apparatus off with. And the thing to observe is the light intensity. The light intensity when it's in the non-electrolyte standard is very, very dim. The non-electrolyte standard has a small amount of impurities in it due to the CO2 that dissolves in it that cause it to conduct electricity to a small extent. Theoretically, pure water wouldn't conduct electricity at all. So you should take note of that intensity when you're doing your experiment, or as I'm doing it right now. And if you're testing an unknown solution and you have an intensity that is similar to that, you would say that that unknown is a non-electrolyte. Now next I'm going to demonstrate to you the weak electrolyte, and between most solutions you should rinse with the distilled water, but since I just rinsed with distilled water and the solution I dipped into is distilled water, I'm not going to rinse in between here. It's not necessary. So now I'm going to dip it into the weak electrolyte standard, the 1% acetic acid. And if you look at the LED intensity here, it's a bit brighter. You can clearly see the difference between the weak electrolyte and the non-electrolyte. Now I'm going to rinse that off before I go and demonstrate the strong electrolyte standard. Bring this over so you can see the light intensity. The strong electrolyte standard is the brightest. Yeah, she's leaning the right way. By far, can easily be discerned, certainly in person more easily, than the weak or non-electrolyte standards. Now I'm going to rinse that off certainly because I just had it in the strong electrolyte standard. Even a small amount of that solution could obscure my results in the next part. And now I'm going to dip it into a solution that's an unknown. And the light intensity there is not very bright. It's really quite similar to the non-electrolyte standard. So I would say that this compound that I've dissolved is classified as a non-electrolyte. One last thing is a tip about working with the conductivity apparatus that may give you confusing results if you are not careful about. The way that the apparatus works is that the electricity that flows out of the battery comes through in this direction, and if the electrode is held like this out in the air, there is no electrical connection between this point, and electricity can't be conducted. But when it's dipped into a solution that potentially contains ions, those ions would allow electricity to be conducted, and the electricity can flow from this point through the solution and continue to flow through the circuit by going to this point. Then it comes up here and it goes through the LED if it can succeed in flowing and lights the LED up. If you're not careful handling the apparatus though, you may bring these two wires close to each other. These are the two leads of the sensor. And if you make a connection between the two of them like that, that will light the LED up also. That's a short circuit. If you do that, the electricity is simply coming up like this, and it's going right through the LED and not going through the test solution. So as you work with the conductivity apparatus, keep the loop of the circuit open like this to avoid a short circuit from occurring and giving you the false impression that something is a strong electrolyte. Okay, so I'm going to show you a little bit about how to use the conductivity apparatus and how to clean it in between its uses. So before you use it for any testing, you should always wash it off with distilled water. And our distilled water is this bottled Big Wind water. Now the first test I'm going to show you is if I test the bottled Big Wind water itself, because the bottled Big Wind water is very close to being pure water, and water is a non-electrolyte. So if I dip it in here, this is how you do the test, and you look at the electrodes of the LED's color. Now come in close with the camera. Come in very close. You see that faint green color? That's because a little bit of electricity is being conducted by that solution. That's only really mostly due to impurities. Right? So that faint color we will call a non-electrolyte if we see it for other solutions. Okay. So for comparison, I'm going to show you what tap water looks like. And usually you have to wash between, but I just took it out of Big Wind water. That's what we wash with, so I'm not going to wash here. And I'm going to put it right into the tap water. And if you look now at the LED, if you look closely, you will see the tap water is a bit brighter. So the Big Wind water is truly purified water.